Hi guys, good evening. So in the last session, we saw about your ping ICMP and ARP concepts. So in the ARP, we saw about your normal ARP and we saw about GARP. Also, we saw that reverse ARP and inverse ARP we do not use in the networks. Now today we'll go with the default gateway proxy ARP telnet and SSH configuration. So first of all, let's talk about default gateway. What is default gateway? So you can consider this thing as an example. Consider this is a classroom. Okay. And this is one more classroom we have. Now, if we have a classroom, that means we have a gate also. These classrooms, they are going to have a gate. Okay. Now what? Let's consider that this is your classroom, which is for CCNA, and this classroom is for CCNA. Now in CCNA classroom, we have certain students. Okay. Some students are there in the CCNA and some students are there in the CCNP. Okay. So if these CCNA students, they want to communicate with themselves only. If you guys want to communicate within the classroom only, then do you need to pass through any of the gate? No, because all of you are sitting here. So you don't have to go through any gate just to have communication within yourself. Correct? But if CCNA student want to have communication with CCNP students, then they have to pass through the gate, right? So now what is this classroom? The classroom is what? Network. So whenever you want to have communication within a network, you do not require what? Any gate or a default gateway. But whenever you want to communicate from one network to another network, then you have to pass through the gate. So what is the gate? The gate is the point from which you will be exiting your network. In technical term, how we'll say that your default gateway is the exit point of your network. The point of your network from where your traffic will exit the network. And from where it will exit the network? From the router, because router is responsible for providing communication between different networks. So your router IP address will be used as default gateway. This thing is clear? So now let's design a lab here. So I'll take a router. With this router, I'll connect two switches. And then I'll connect PC. Okay, so let's consider on one side we'll be using the network. 1.0/24, 2.0/20. Here I'll be using 1.10. This side I'll be using 2.1.1, 1.2, 2.3, 2.4. Okay, as per the device number, I have assigned the IP address. Okay, so let's go and assign these IP addresses. One dot one. Right now, I'm not assigning any default gateway information here. One dot two. 2.3. 2.4. Now let's assign on the router. Terminal host name, I'll give it gateway. Gig 0/0 IP address 1.10. No shutdown. G0/1. 2.10. No shutdown. Done. Right now, if I will try to communicate from PC1 to router, I will be able to communicate, and from PC1 to PC2 also I will be able to communicate. Why? Because this is the same network. So within a network, we do not require any default gateway here. So if I will say ping 192.168.1.2, I will be able to communicate, as well as if I will communicate with .10 also, I'll be able to communicate. But I will not be able to communicate with the second network. Why? Because if I want to communicate from CCNA classroom to CCNP classroom, I have to pass through the gate. So I must have an understanding that where is the gate, right? I must have an understanding that where is the gate. Like this classroom, if you don't know where is the gate, how will you go out? You don't know, right? So somebody has to tell you that, okay, this is the gate, correct? So the same thing, we will provide the information here. So first of all, let me try to ping, let's say 2.3. So I will not be able to communicate because my PC doesn't know how to go out of the network. Although it knows that, okay, this is router, but it doesn't know that, okay, from here I can exit it. Okay. See, no communication. So for having communication, what do we need to provide? Gateway. So gateway will be what? Router's IP address. And your gateway IP will be same network. It should be in the same network only. It should not be from different network. If I'm using 1.1 network, that means my 1. Network should be the gateway only. So here my gateway IP address will be what? 1.10. And this side my gateway IP address will be what? 2.10. This is clear? So let's go and provide it. 1.10. So let's just go and provide everywhere only. Now what will happen? I have provided gateway this side, but I haven't provided this side. So my request will come up till here. But when these guys will try to respond, they will say, okay, I have to respond to 1.1, again, different network. So these guys should also know about the gateway. Otherwise, how they will reply, right? So here also we will have to provide gateway. Even right now, see, on one part, I have provided the information about gateway. Here I have not provided. So I will not have the communication because the reply will not come, right? That means this guy is writing me a letter, but this guy don't know how to reply back. What is the address, right? Same thing. So right now, if I try to communicate, you will see here, okay, if I go and capture the simulation for ICMP, See here. This message will be generated. Okay, so one message will fail. Why? Because of the ARP process. Now this second message. See here. This message will come here. But again, this guy doesn't know how to reach here because we haven't given default gateway here. So we have to provide default gateway information here also. So here the gateway will be what? 2.10. Okay. And once we have it, now you see. Once you have default gateway, you will be able to communicate between different network also. Clear? Okay. This is your default gateway. Now let's talk about proxy ARP. So what is proxy? In universities you might have used. No? Very sincere. Hmm? You guys were very sincere. Anyone use proxy in school or college? College? What is proxy? Proxy attendance. You're not going, your friend will say present. That is what? Proxy. So basically what is happening? Your friend is acting on behalf of you. When the professor will call out the name, he will say present. He is not you, but on behalf of you, he will respond. Same thing happens in the network also. Okay. So consider this scenario here that I have a router and then I have two more routers. When we studied about ARP, we studied about ARP cache, correct? This router will be acting as proxy. So let's say what I'll do is this side I'll use 10.110/24, 10.220/24. Here I'll assign 10.111. Here I'll assign 10.112. Sorry, 10.2. This side I'll use 10.110. Here I'll use 10.2.10. This is clear. Now let's do the configuration first. So first of all, I'll assign the IP addresses only. Router 1. Enable configuration terminal, hostname, router 1. Interface big 0/0, IP address. Done. And this is what my R1 is. And this is R2. Interface big 0/0. IP address 10.2.2.2. No shutdown. Done. Hostname. Add. This is done. Let's configure the proxy route. Enable configuration terminal. Hostname we can say. Hostname is what? Proxy interface gig 0/0. IP address. So on gig 0/0, what is the IP address? 10.1.1.10.255.255.255.0. Note it down. 0 by 1. 10.2.2.10. No shutdown. Okay, so you can see I'm not using the complete comments. I'm just using abbreviations for interface IN, right? For IP address, I'm using add only. For no shutdown, no SH only. So like this short forms you can use. This will help you to do what? This will help you to do the configuration faster. Okay. Like instead of configure terminal, I just said what? Conf T, right? And instead of host name, I used host only or HO only you can use. So whatever the keyword you want to use, that has to be unique. Okay, like for host name. So if I'm using HO only and if there are two comments, so this will not work. It has to be unique. Like if I say HOS, that means after HOS, there is no other comment, only hostname comment is there. So it has to be unique. Okay, so like that I'm using here, like for enable, I just use EN only. Okay, so short forms you can use. All right. Done with the configuration. Now understand. Initially, ARP cache for every device will be empty. There will be no entry in anybody's ARP cache. Nobody will have MAC addresses for anyone. Okay. So ARP cache on this router, let's say for example, in the ARP cache we have IP to MAC mapping, IP to MAC mapping empty it is. Okay. And here also this will also be empty. So in case of router will have their own information, but they will not have any other information. Like R1 will not have information about proxy or R2, and same way R2 will not have information about proxy or R1. Same way proxy will have information about itself only, no information about R1 or R2. Now see here. This is ARP cache for your proxy. Okay. Now what? Let's say I will go to R1 and on R1 I'm giving a command, something like ping 10.2.2.2. So first of all, my R1 will generate what? ICMP message, correct? So I will generate this side. It will generate what? ICMP ARP request. And in this, it will say source IP 10.1.1.1, destination IP 10.2.2.2, source MAC address. So it will be R1. Let's say M1 is the MAC address. Okay. Let's consider here this is M1. This here it is M2. This one, let's say M3. And let's say M. So here destination MAC it will check. So destination MAC when it will give, it will say I don't know about destination MAC because the ARP cache is empty for router 1. So there is no entry. Clear? Here in the R1 MAC cam table or ARP cache, sorry, in the ARP cache there is no entry for 10.2.2.2. So what it is going to do, it is going to generate a ARP. So it will generate a ARP request here. This ARP request, it will have the source IP 10.1.1.1, destination IP 10.2.2.2, source MAC address M1, destination MAC. So it is a ARP message broadcast. Now what will happen? This message will go from here to router. First of all, this is a layer 2 protocol. Second reason, this is a broadcast message. So your router will never forward it this side because each interface of router is in a different broadcast domain. So it is not going to forward this side. And if your router will not forward this side, that means ARP message will never come to the R2. And if never come to the R2, R2 will never give the MAC address. If no MAC address, this information will never get completed. And that means there is no communication. Now what will happen? To avoid this kind of scenario, when R1 will send this ARP request to router, what this proxy router will do on behalf of R2, it will respond. On behalf of your R2, this proxy router will respond and it will give its own MAC address. Okay, so how the router is going to respond? In the ARP response, the router is going to say something like, this is the ARP reply, and let me call it proxy ARP reply, because router will respond. So router will say source IP 10.2.2.2, destination IP 10.1.1.1, source MAC address M3, destination MAC address. So when this ARP message will come to the router, router will make entry of R1's MAC address. Okay. When this request will go to the router, router will make an entry that, okay, I received a packet from 10.1.1.1. So here it will make an entry basically that from 10.1.1.1 I received. And what is the MAC address here? M1. So like this, it will make an entry in the ARP cache. And when it will generate this message, it will say that, okay, destination MAC address. So for 10.1.1.1, what is the MAC address? M1, M1. Now the information is complete. So this proxy ARP reply, your router is going to send to whom? R1. Once R1 will receive this proxy ARP reply, what R1 is going to do? R1 is going to mark here that, okay, I received a reply from 10.2.2.2 and MAC address is what? M3. So this is why it is known as proxy ARP. Because what your router did, your ARP request never came onto the R2. But on behalf of R2, your proxy router is saying that, okay, I am 10.2.2.2 and this is my MAC address. Hmm? The request came, right? The request was going for 10.2.2.2. So for this, in the request, he says that the request is going for 10.2.2.2. But due to broadcast message, it cannot forward on the other side. So it will say on behalf of this guy, I will respond. Right? On behalf of this guy, doesn't matter, any IP address it can be. Router will use the same destination IP address in the source. Whatever the destination was there in the request, that same IP address. See here. Source becomes destination, destination becomes source. This is a pattern of request and reply. That if you are sending a request, so in the request, whatever is the source, in the reply, it will become destination. And whatever is the destination in the request, that will become the source in the reply. So that is a pattern. So this way, source, your router just picked up this address and started replying. And router replied with its own MAC address. So this is known as what your proxy is. This is clear? Any doubt? Online people? And proxy ARP will be there in case of router only. It will not be there in case of PC. Okay, why? Because your PC will never generate an ARP for the destination. PC always generate ARP for only your default gateway. And default gateway is always in the same network. So that means ARP doesn't have to go out of the network. And if your ARP doesn't have to go out of the network, there is no proxy ARP. Okay, so in case of PC, there will be no proxy ARP. Only in case of router, it will be there. Is that clear? All right. So this thing is clear to everyone? Now the thing is that this router has to communicate with a different network. So in normal scenarios, we have to do routing. But as of now, we haven't discussed about routing. So what I'll do, I will disable the routing features on these and I will provide default gateway. Rather than providing a route, on the router also I'll provide a default gateway. But for that, what I have to do, I have to disable routing. Okay. So how you disable routing on a router? See, there is a by default command given on the router, IP routing, which enables routing on the router. So what I need to say? No IP routing. This will disable the routing features. Now what? I need to give default gateway also. So I will use the command IP default gateway. And what is the default gateway for R1? 10.1.1.10. For this one, 10.1.1.10. Done. Same thing we will do with the R2 also. No IP routing. Oh, not here. Global configuration mode. And I'll say IP default gateway. What will be the default gateway IP here? 10.2.2.10. Okay, this is done. All right, now we will capture the packets and we'll see the proxy ARP and everything. So go to the simulation mode and we just want to capture, let's say, ICMP and ARP. Okay, so here you will come to know about the proxy ARP. Now let me go here and say ping 10.2.2.2. How many messages got generated? Two. First message will be ICMP, in which we do not have the layer 2 information. MAC address information is not there. And second message will be generated, which will be ARP. The ARP is going from 10.1.1.1 to going to 10.2.2.2. That means generated for the destination. And it is a broadcast. Now your green message is the ARP. So first your green message will travel. Now, since this is a broadcast, router cannot forward it on the other side. So what router will do? On behalf of R2, router will respond. See, this is the incoming packet coming from 10.1.1.1.2 going for 10.2.2.2. And this is the outgoing packet going from 10.2.2.2 to 10.1.1.1. See here. So directly it is sending back here only. This message will never come here. And this response is what your proxy ARP response. Is that clear? That your router in between is acting as a proxy. Okay, my destination is what? 10.2.2.2, but my packet never reaches here. Okay, so your router is giving its own MAC address. Now this guy will think, okay, I got the MAC address for 10.2.2. So what will happen? This guy will send the ICMP again now. And in the ICMP, it will have the information about layer 2 also, because it got the MAC address. Now see what will happen. Router gave its own MAC address, but did router check what is the MAC address of this guy? No. Router did not generate any ARP here. So still your router, proxy router, does not know where is ARP. So it is like on behalf of anybody you gave the attendance, you don't know where is the guy. Okay, same scenario here. Now this ICMP will come here and router will think, okay, somebody came looking for this guy, but I don't know where is he. Okay, so what your router will do on behalf of this? See here. I can use it like this. Okay, now see here. What is generated here? ARP. Because even your proxy router did not have the MAC address of this guy. Okay. So now what? See here. This is ARP going from 10.2.2.10 and going to whom? 10.2.2.2. So it is the same network only. So normal ARP request and response. So one packet was dropped here initially because router did not have the MAC address. Second packet got dropped here because this router didn't have the MAC address. Two packets were dropped. Okay. Now this router will check what? What is the MAC address of this guy? Got the MAC address? Now this guy will send the third ICMP packet. This is the third ICMP packet. And since R1 got the MAC address for this, which was given by the router, and router knows where is R2. So this packet will travel up till R2. But now R2 will say, I don't know where is this guy. R2 also needs MAC address for R1. So what R2 will do, see here, source is, destination is, type is, that means again what is going to happen? Proxy. Because again this is a broadcast, router will not forward it this side. So this time on behalf of R1, router will act as a proxy. So see here, ARP came. If I open it, the packet that was incoming from 10.222 to 10.111, and the outgoing is from 10.111 to 10.222. That means packet will never arrive here. This is again proxy. Now this guy also knows MAC address. So 3 packets got dropped. Now the 4th one. Now everybody knows about everybody, so they will have the communication. Okay. Packet number 5. Now no problem in the communication. Okay. And you can see that I have out of 5 packets, only 2 were successful. So my success rate is 40%. Now, one time I got the MAC address. Now, next time I will have 100% success rate. See here. Clear? Online people? Proxy ARP is clear? Yes or no?
Yes, sir.
All right. So it will be there in case of router only, will not be there in case of PC. Now, next thing is about Telnet and SSH. So how many ways you can access a device? Number 1, you can have physical access. Number 2, you can have remote access. Physical access we have seen, you can have it using console cable through the console port. And remote access, you can have in again 2 ways. Okay, remote access again, you can have in 2 ways. One is if you want a CLI access or if you want a graphical access. Okay, CLI means command line interface. And GUI means graphical user interface. If you are looking to access via CLI, you have options like you can go with the Telnet and you can go with the switch. Okay. Telnet is insecure, SSH is secure. If you want graphical access, then again you can go with HTTP or HTTPS. These are the ways you can access a device. So right now we'll go with the Telnet and SSH. Noted? Done. Okay. Now let's talk about Telnet and SSH. First of all, let's talk about Telnet. Telnet can be authenticated, or you can say different ways of configuring Telnet. That is also fine. Following ways. Before that, first of all, let me explain Telnet. If we talk about Telnet, your Telnet stands for Terminal Network. Okay. And it is a remote access protocol. It uses port number. What is the port number? What is the protocol number? Protocol number. Protocol number for Telnet. Hmm? What is the protocol number for Telnet? This was the task, right? Hmm? I said you have to find both port number and protocol number. Correct? Then I mentioned if some protocols are using two port numbers, why two port numbers? In some protocol is using two different services, TCP and UDP, why they are using it, all these things. Okay, which service it is using, TCP or UDP? All the TCP based protocol, HTTP, HTTPS, DNS, DHCP, or whatever the protocols are there, like DHCP is using what? UDP. DNS uses both, then SMTP and all these protocols. So whatever the protocols are TCP based, they will always use protocol number 6, because eventually protocol is what? TCP, right? They will use protocol number 6. And any UDP based protocol, they will use protocol number 17. Sometimes in the interviews, they will ask like this, that they will say, what is the protocol number for, let's say, for example, Telnet. And students, they will be very confident and say 23. Okay. And this is where they make a mistake, showing that, okay, we are completely impatient, right? And this also shows what? Overconfidence, that you are not listening to the question. Presence of mind is not there, right? So be very careful in the interviews, because in the interviews, it is not mandatory that you have to answer on the spot. No need to do it. If an interviewer is asking question, take 5 to 10 seconds of time. No hurry. Understand the question. Then frame your answer. So if you will take 10 to 15 seconds, it is not a big deal. Okay. And then once you frame your answer properly, then start explaining your answer. Rather than, sometimes when it is asked in the interviews, what we'll say? Telnet remote access protocol and port number 23 and like this. So rather than explaining like this, if we explain in a flow, that shows your technical expertise. Okay. So it is very important that you take care of these kind of small things. Like right now, I said, what is the protocol number? And one answer came 23. Correct? So don't use it. You can say protocol number 6. Okay. The service is provided by TCP, or you can say it uses TCP service. Then after, Telnet is vulnerable, or you can say insecure. Why? Because Telnet transmits entire data in clear text. So if someone is sniffing your network traffic, they will be able to see what are your usernames, what are your passwords, what are the comments you're typing, what is the effect of comment, everything. Whatever the communication you are having, the same communication they will be able to see without connecting to your router and without connecting to your system also. Is that clear? So Telnet is highly vulnerable. Now, why everybody is able to see? Because the data is in clear text. So if I open it, I will be able to see it. Okay. Then, other than this, what else we can say about Telnet? Vulnerable, clear text. Okay, that is, I think, pretty much it. This is clear. Okay. Now let's talk about how you will be configuring Telnet. Before that, let me also explain SSH so that you can compare it. So if we talk about SSH, SSH stands for Secure Shell. Okay, again, this is also a remote access protocol. Easy, easy. This is also a remote access protocol. And what is the port number? 22. And one more thing, whenever you are explaining about port number, don't just speak the number, always mention the service also, whether TCP or UDP, because port numbers are available in both TCP also, UDP also. So whenever about a protocol is asked, you have to be specific. Okay, don't answer like if I say SSH port number, so don't say 22 only, say 22 TCP. Okay. So second one, right? Remote access protocol. Okay, remove. This remote. Uses port number 22. Okay. And then you can say it uses protocol number. So like this also you can explain that uses port number 22 and service is provided by TCP, or else simply you can say port number 22 TCP. Both are fine. Okay. It uses TCP service. And start learning about DNS protocol in detail. SSH is secure. Why SSH is secure? Transmits entire data in encrypted form. Okay. In the encrypted format. And which algorithm it uses? Uses RSA encryption algorithm. Okay. Then there are two versions of SSH. SSH version 1 and version 2. And definitely if newer version it is, then it is more secure. SSH version 2 is more secure compared to SSH version 1. That is enough about SSH. Encryption, see, like rather than transferring the data, let's say, for example, I want to send you a message, hi. But this message, one is I'll say normal hi. So if anybody will see your phone or anything, they will come to know that what is the message I'm sending. But let's say I don't want that if my data somehow somebody is seeing also, they should not be able to understand. So I can start having encrypted communication. For that reason, I can use encryption algorithm. Now, what is encryption? Encryption is a process of converting your plain text into ciphertext. Ciphertext means you can say kind of a language that is not easily understandable. Okay, so if you want to see, let's say practically, if I want to show, so let's say Okay, so like this is one which is using AES algorithm. Okay, so let's say I want to send a message hi to somebody. Now normally what will happen, that I will send hi, and if anybody sees the information, they will come to know what I'm trying to say. But if I encrypt this information, now it is converted into this. Now nobody will be able to understand. And the person I'm sending this thing, they will know how to decrypt. So they will just go here and paste it, and they will say decrypt. They'll get the message hi. This is one thing. But now you can say, what if anybody goes and paste in this website? This is also possible. So here I have an option that I can encrypt with a custom secret key. So that means I will share this key with the person whom I want to share the message. So let's say I'll say that, okay, my secret key is what? Cisco. Now I will encrypt it. Changed. Copy. Paste. Now if they will try directly, no decryption. Why? They have to know the correct key. If they know the correct key, exactly. So this is what my encryption key. So this is the AES algorithm. RSA is even more secure than this. Here I'm using only one key. In RSA, we have two different keys. One key is used for encryption and second key is used for decryption. So the encryption key I will share with everyone that, okay, if you want to send me information, then use this key to encrypt the traffic. Now I have the second key and only I have it. So only I'll be able to decrypt that information. Nobody else will be able to decrypt the information. And if you want to see how RSA keys look like, that also I can show you. This thing, this is here. How RSA keys look like. So first of all, let's say I want to generate a key. I'll say generate keys and see this is how they look like. Very big. So not easily, like nobody can easily remember these keys. Okay, this is how big of a key it is. And it is completely random text. Is that clear? So it is not easy to predict these keys. So this is the public key, which is used for encryption. And this key I will share with everyone that, okay, if you want to send me information, use this key to encrypt it. And after that, I have this private key. So this private key, only it will be with me, correct? And if it will be with me, that means only I can decrypt the data. If somebody will use this key to decrypt, cannot. In C, there are two types of encryption. One is symmetric and second is asymmetric. Symmetric, only one key. For encryption also, decryption also, that we saw here, right now, in this one. In this case, we saw, right, that only one key, Cisco, I used, correct? So that was what? That was symmetric encryption. One key, same key for encryption, same key for decryption. RSA is asymmetric encryption. Two different keys, one for encryption, one for decryption. Is that clear? Online people?
Yes, sir.
So now if you also want to have a secret communication, you know the trick, right? There are so many ways you can have, secret communication. Like you might have seen the agencies like RAW and, intelligence bureaus and all. Their agents are working worldwide, right? So do you think they will be sharing the information like this, that hi, hello? They don't share directly. Okay, they will be encrypting the traffic. Then they will again not directly send the message. They talk in the coded form, correct? So again, if I want to send a message, I can hide my message within an image. In a photo, I can hide my message and then I can send it. If somebody knows how to read it, they will be able to see it. Otherwise, nobody will be able to see it. Like small practical, if you want to see for this also, I can show you. Now, let's see, this is an image for sunrise, right? Now, in this image, do you think there is any message? Doesn't look like it, right? Even I don't know if I have put some message or not. So let me do one thing. Let's download a new image. Okay. Let's say everybody likes puppies. Okay, just download any random image. Let's say this one. Now this is a good one. Let's save it on the desktop. This is in the WebP format. I need to change it. Let's see whether the image is there. Oh, this is there. Now what I'll do, let's say I want to share a message, a secret message with one of my agents. So what I'll do, I'll simply open my command prompt. So there's the problem. Okay, I'll go to where desktop. My picture is available where on the desktop, and I'll check here that this is my copy.png. So I'll use echo and I'll say that hi, this is my top secret message. Okay. And I want to put it inside the copy image. Done. Now, if I will open this image, let's see if you are able to see any change in the image. No, right? So if I will send this image to somebody, they will not be able to see anything. See, it is just the image only. So if somebody knows how to read it, they can read it. Otherwise, nobody can read it. Now, how to read it? Just go here and say open with and open your image with a notepad. If I open this image with notepad, I'll say open. Now wait for it. It will take some time. I think larger image. See? This is how it is. Now here I can go and say word wrap. Oh, do you understand anything? This is Chinese language. Okay, here it is not there. We need a JPEG image. Still it is loading. Okay. Yeah, in PNG it will not be there. It will be there in the JPEG. So let me do one thing. I'll open it with Paint. File, save as. Yeah. On the desktop. This is the new image. This is PNG, so I will delete it. Oh, let me check. Might be that our old message is already there. First of all, I'll open it with Notepad and I'll check. It is possible that our old message is already there. No, it is not. So let's add the message. Desktop. This is my secret matches, and I want to add it in the copy. This could be because of enough privilege also. Let's check. Got it? So this is how we can get it. Now, if I send this picture to somebody in the WhatsApp, nobody will come to know that what I tried to send. And after this, I can write, okay, see how good this puppy is, how cute he is, right? And nobody will suspect anything. And this way we can have communication. And right now, this communication was in plain text. I can encrypt this data. I can share the key already with them, and then I will share the encrypted data too. There is no possible way to understand it. This is how secret communication happens. Got it? This was something extra. So now you got understanding of encryption. So this what we did in the image, this is not encryption. This thing is known as steganography. It is a cyber security term. Steganography. Okay. Right now we have hide the data in the image. We can also hide in the picture like movie, audio, anywhere we can hide. Okay. Clear? All right. So let's go and configure Telnet now. So Telnet can be authenticated in following ways. First of all, you can authenticate Telnet using password. And Telnet is insecure. Sometimes it will give you access without password also. Okay. So if you want to authenticate using password, okay, before this I need to explain something else. We have something called as VTY lines, virtual terminal lines. Virtual terminal line. Or we call them as a VTY. These are virtual lines on the device. Okay. Total 16 lines are there. These are virtual, nothing physical. Okay. So don't think there will be something coming out of the router now. There are 16 lines and their range is from 0 to 15. With each line, one user can take remote access. That means total how many users can take the access at a time? 16 lines are there for 16 users. A total of 16 users can take remote access simultaneously. This is clear? Okay, that will depend on our configuration, how many lines we configure. But by default, 16 are there. Okay, this is clear. Then one small introduction to the privilege level also we can take here. User privilege. groups. There are 15 privilege levels. Okay. Range of privilege levels 1 to 15. Okay. 1 to 15. 1 is the lowest privilege level. Okay, 1 is the lowest privilege level. At this level, user will get access to user execution. Okay. And in the user execution mode, we know that how many comments we have. Okay. So if you create a user and you do not assign a privilege, by default, privilege level 1 will be assigned. Okay. So this is the default privilege level assigned if a user is not provided with the privilege. Clear? And 15 is what? The maximum privilege level. 15 is the highest privilege level. At this level, the user has unrestricted access. Unrestricted access means can do anything. This is clear? Okay. Now let's go and configure Telnet. This is clear? Okay. So first of all, we can authenticate the Telnet using password. How you will authenticate? You will go to the global configuration mode. You will use the command line VTY. Then how many lines you want to configure, depending on how many users you want to give access to. So minimum of 2 users you can give access. Okay, so here you have to give the starting line number and after that ending line number. So if I'm giving access to 2 users, I can say 0 to 1. If I want to give access to 5 users, 0 to 4, like this. Okay, then I can configure here password, and whatever the password I want to configure here, let's say 123, and then I can simply say login. This is my Telnet configuration done. Okay, we don't have very big configuration, 2 lines, 3 lines, that's it. So this is my Telnet configuration done. I can go and configure it in the lab. So what I'll do, I'll take a router here and I'll take a server or any PC also I can take, no problem. R1 PC. The IP address that I'll configure here, 10.1.1.1. Here I'll configure 10.1.1.2 and subnet mask I'll keep default. Same network, so we don't require default gateway. Done. Go to the router. CLI. No. Right now I'm configuring Telnet, so let me change the host name to Telnet only. Interface big 0/0. IP address 10.1.1.255.0.0.0 and no. Clear? Now let's configure Telnet. So right now, if I try to take a Telnet access from this PC, so how I'll take? I'll say Telnet and 10.1.1.1. So it will not allow me to access. Why? Because Telnet is not running there. I haven't configured Telnet on the router. So what I'll do here, I'll go on the R1 and I'll configure Telnet. So how we will configure? We'll simply say line VQA 0 to 4, let's say, password 123, and I'll say login. Done. Now if I go here on the PC, And if I try to take an access, same command, telnet 10111, asking me about password. I'll give password and give it, right? Okay. So this is how you can take a telnet access. But this is only asking me for password. But what if I have multiple users in my multiple admins in my company? So what I want to do, I want to give them, I want that they should be able to authenticate using username and password so that I can know which user did what. Otherwise, anybody will use password. I'll not come to know who did what, right? So for that reason, I'll exit from here. Now here I'll show you something interesting. That see, I did the telnet configuration. Let me do the reverse configuration. No login, no password, 1, 2, right? And if I go and try to take a telnet access, this is telnet vulnerable. This is vulnerable. You saw without any password also getting me access. Okay. Not one time. I removed the which one? Again, if I say telnet doesn't matter. So this is because of vulnerability that okay, it has a bug. There is a bug. Okay, that's why. Now what? Let's say I want to authenticate using username and password. So how we'll do it? Authenticate using local user database. Okay, we can authenticate using local user database. That means locally I can create users and I can authenticate using those. So how I'll do that? I'll say, first of all, I'll create username. Let's say one user I'll create as a guest user. Okay, and this I'll create with the password. Okay, and the password, let's say again guest. Okay, so this is a user. I'm not assigning any privilege. So this will by default get privilege level 1. And then if I want to assign privilege, so let's say username, admin, I will assign privilege highest, and then I will assign password. Let's say system. What is going on? Problem. Don't know what is their problem. Okay. Then what? You will say line VTY 024. And this time I will say, see, password is already set with the user, so I don't need to give the password command now. I'll say login, but login using the local database. 3 lines command again, only 3-line configuration. So let's go and do it. So here, I'll exit here, and I'll say username. First of all, let's create the guest user. Password. There. Then I'll say username, admin, privilege I will assign. The privilege is 15, and password. Done. Now let's configure the lines. Line VTY 024 login. Look. Now if I go here and check, asking about username. First of all, let's go with the guest user. Password. Which mode? User execution mode. If I try to go to the privilege mode, I don't have access to the privilege mode. And if I try to check what is my privilege right now, privilege level is 1. Here you can see my privilege level is 1. That is the lowest privilege. And in the lowest privilege, if I try to check the running config also, I'll not be able to check. Is that clear? Okay. Now what? Let's try to log in using the admin user. Sorry. Telnet admin password is system. Again, username is admin, password is system. Privilege mode. What is my privilege? 15. Now I can go to global configuration mode and whatever I want to do, I can do. I have unrestricted access. I can change anything in the device. Is that clear? So this is how your Telnet can be authenticated using local user details. Clear? Now let's talk about SSH. So SSH you can authenticate only using username and password only. That means local user database. Without username and password, only using password without password, that is not possible in SSH. Okay, but before that, what I want to show you is how Telnet is vulnerable. See, I'll take a Telnet access. What it is asking me? Username. Now let's say somebody is there in the network who is capturing the packets. Okay, so right now I'm going for Telnet, so I'll capture Telnet only. Okay, so somebody in my network is capturing packets. So as an admin, I don't know somebody is capturing the packets. I will go and type my username. Okay, okay, I already typed wrong. See, any key I will press, it will be recorded. Okay, so let me do it again once. See, I don't know. Go here, and now I don't know that somebody is capturing the packet. So what I'll do? Again, I type wrong. Just one moment. Correct username I want to show. By mistake I type this code. Go to real time. Okay, simulation, somebody is capturing, we don't know. And here I'll type username I type. Now you see some packets got generated. So if somebody is capturing these packets and they will just open these packages, okay, when they will open the packet, this is a Telnet packet. They'll go to the information inside the packet. What is the information? A. Second packet. B. Third packet. M. Fourth packet. I. Fifth packet. And got it? So right now I'm showing you single packet, but there are tools available that will show everything. They will collect everything and they will format everything in a proper format. And then you'll come to know. So this is the problem, that it is transmitting entire data in the clear text. Okay. Got it? Now let's go with the SSH configuration. So Telnet is vulnerable. That's why we prefer what? SSH. So here you can add one point that it is suitable for LAN networks. That LAN network is my trusted network. So I can trust there. This is suitable for LAN networks, and SSH, you can use it in the LAN or WAN, up to you. This is suitable for LAN and WAN. Clear? Now let's go talk about configuration. This is Telnet. This is about user privilege levels. Virtual terminal line. Telnet. Switch. And this is okay. Now for SSH, there are certain requirements that you have to fulfill. What are the requirements? Requirement number 1. Hostname should not be default. Second requirement. Domain name should be configured. Encryption keys should be generated. Then after user should be created. And number 5, VTY line should be created. Okay, these are the requirements. If you want to change the host name, how you'll change the host name? You'll use the command host name and whatever the host name you want to give here. Name you'll give. So as of now, let's say for example, I'll change it to SSH. Then domain name should be configured. So let's say domain name I will configure. IP, domain name, and let's say I work in Cisco, so this is Cisco. Okay. Encryption keys you have to generate. So you'll use the command crypto key generate. RSA algorithm you want to use. General keys modulus. See, SSH has two versions, version 1 and version 2. And I said version 2 is more secure. So if you want to enable version 2, your key size should be at least 768 bit. At least 768 bit should be there. Okay, here you can give anything between 342 4096. But you have to know that higher the bits of encryption, more CPU it will use. Your device, more CPU it will use. But higher the encryption, more security it is. So depending on your requirement, you have to adjust a bit. Okay, so let's say I can go with 1024 or 2048. So as of now, let's say I'll go with 1024. Okay, so once keys are generated, then I can go and create the users. So I can say username, Cisco, privilege 15, password. Cisco. User is created, then I can go and configure the VTY lines. So I can say line VTY 024, login, local, and that's it. So if you see here, one thing is there that if you focus on this part and this part, what is the difference? No difference, correct? So that means what? When you configure SSH, automatically your telnet is already configured. When you configure SSH, telnet also will also be enabled. But telnet is vulnerable. I want to use SSH for security. I'm configuring SSH, but again, telnet is getting enabled automatically. So it doesn't matter. Same username and password is applicable for telnet also. That means if somebody will access using telnet and he will provide username and password, will be able to access, right? And if somebody is capturing packets again, problem. So what we can do here, we have an option. We have one extra command. Here we can use one extra command. That extra command is what? Transport input SSH. Okay, so after transport input, I get 4 options. After transport input, I'll get 4 options. One is SSH, telnet, none, all. Right now I said what? SSH. That means only SSH will be enabled. If I say telnet, only telnet will be enabled. If I say none, both will not be enabled. And if I say all, both will be enabled. Got it? So these are the 4 options I'll get. So right now I'll use what? SSH. And how did we access your telnet? To access telnet, we use the command telnet, and after that we give IP address. Right? This is how we access telnet. But at the same time, if you want to access SSH, Okay. If you want to access SSH. So in that case, you have to say SSH -L, and after that you have to give here the username, whatever the user you have created, and after that you have to use the IP address. This is how you will access. Okay. Clear? So let's go and configure these things one by one. I'll go here, I'll go on the router, and I'll just restart it for showing you about the fresh configuration. Fast forward. No, enable configuration command. See, directly if I try, these are what I said, these are my requirements. So directly without setting host name and domain name, if I try to create the keys, I'll not be able to create. Okay, see here. I'll say directly I'll try to say, first of all, let me give the IP address and all. So interface big 0/0 IP address 10.111.255.0.0.3. Okay. Now let me directly try to create encryption keys. So I'll say crypto key generate RSA general keys modulus 1024. What it says? We have to change the host name. Host name SSH. Let me try again. Domain name also you have to define. IP domain name Cisco.com. Now I can go and generate. Now no problem. And you see what it says? Version 1.99. That means version 2 has been enabled. Now I can create the user. Username Cisco. Privilege 15. Password Cisco. Okay. Then I can say line VT1 024 login. Okay. Enabled. Now I can go and access using SSH. So if I go to the PC and if I say SSH-L username is Cisco and IP address 10.111. Asking password Cisco. But there is a problem, like I said, Telnet will also be enabled. Cisco. Telnet is also giving the access. So I don't want Telnet access. So what I'll do here, I'll just go and give that command. Transport input SSH. And now let's go and try to take a Telnet access first. No access. And if I try to take SSH, see, I'm getting the access, right? Now, what if somebody is capturing this traffic? We have to see whether SSH is secure or not. So let me say, asking for password. Let me go here and instead of Telnet this time, SSH I will capture. Now I will type in password and again those packets will be generated. Generated. If I open these packets, you can see this is SSH packet. Scroll down what it says. Encrypted data. Here, all data is encrypted. So that means if somebody is sniffing the traffic also, they will not have access. And your SSH uses RSA encryption, which is asymmetric encryption, two different keys. So this is unbreakable. Is it clear? So this was about your Telnet and SSH configuration. Any doubt? No. Default gateway, proxy, ARP, Telnet, or SSH? No doubt. Online people?
Yes, sir.
So tomorrow we'll go to the lab. Okay. So online people, if anybody wants to visit tomorrow, so they can come. 5 to 6 we will have a session where I'll explain about, first of all, routing and all. Then after I will explain about how you can take the access of the lab, and finally I'll take you to the lab. Okay, so for online people, tomorrow session will be like 1 hour. That's it. Okay. And offline, if anybody is able to visit, you guys can visit and we can see the access of the lab. Clear? All right then. I'll see you guys tomorrow. Have a good day.